Today we have the following limit to practice. Try it for yourself before I do to see if you know how to solve it. So here's my solution. So we are going to use L'Hopital's rule to solve this limit. So what we do in L'Hopital's rule is we take the derivative of the numerator and divide that by the derivative of the denominator. And the reason why we need to do this is because if we substitute in 0 immediately for our x's, you'll notice that in the denominator we get 1 minus cosine of 0. And cosine of 0 is 1. And 1 minus 1, of course, is 0. And your denominator cannot equal to 0. So this doesn't give us a solution. So we have to do the derivative of the numerator over the derivative of the denominator to eventually change this to a form where we can substitute in for x. So let's go ahead and do that. So taking the derivative of the numerator, we have the derivative of x, which is 1, plus the derivative of x squared, which is 2x, minus cosine of x, because the derivative of sine of x is cosine of x. And that all over the derivative of 1 minus cosine of x. Derivative of 1 is 0, so we leave that out, or derivative of all constants is 0. And then the derivative of cosine of x is negative sine of x. But we had a negative here, so negative times by negative is a positive. So in the denominator now, we're left with positive sine of x. Okay, now let's see if we can evaluate this limit. We'll notice again that taking sine of 0, or sine of x as x approaches 0, gives us 0. And our denominator, once again, cannot equal to 0. It can never equal to 0. But as x approaches 0 now, our denominator is 0. So we need to do L'Hopital's rule again. So we have to differentiate the numerator and differentiate the denominator. So let's go ahead and do that. So the limit as x approaches 0. And then the derivative of this numerator, the 1 becomes a constant. The 1 is a constant, so it becomes 0. And then the derivative of 2x is just 2. And derivative of cosine of x is negative sine of x. But there was a negative here, so it is plus sine of x. And the derivative of sine of x is cosine of x. Now you'll notice that the limit as x approaches 0 of cosine of x is 1, because cosine of 0 is 1. So this is now very important, and the reason why I'm focusing on this denominator is because the denominator is what has been not allowing me to evaluate this limit. I need the denominator to not equal to 0. And here, now our denominator won't equal to 0, it will be 1 as x approaches 0. So we have the limit as x approaches 0 of cosine of x being 1, and in the numerator we have 2 plus, and then the limit as x approaches 0 of sine of x is going to be equal to 0 because sine of 0 is 0. So now we have 2 plus 0 over 1, which is equal to 2 over 1, which is simply equal to 2. And that's the limit solved. So if you found this video helpful, please don't forget to leave it a like and subscribe to my channel. It really does help me out. Thank you for watching.